All right. Well, hello, everyone, and welcome to our Vicinity webinar, Recipes for Successfully Feeding the AI Beast. My name is Lisa Ralph, leading marketing over here at Vicinity, and today I have taken the coveted position as webinar host and virtual MC, which means I essentially get to walk you through three key items for today before we get started. So first, incredibly important, thank you. January has been a crazy wild couple of weeks for us. We are assuming it's probably pretty busy for you. So first, thank you for choosing to spend your morning or afternoon with us. Second, on today's topic, a little bit about what to expect. So it seems these days you can barely hop on a business forum, go to a conference, walk down the street, watch TV without hearing or seeing AI. And today's session hopefully should be a little bit of a different approach to that. We often hear a lot of the power of AI or the software behind AI, the great impact of AI, how to build an AI application, how to identify what AI application to build. But there's still this elephant in the room. And while the elephant may or may not be AI generated, it is still there. And that elephant is that a lot of AI projects tend to fail. And today's spin is geared towards how do you actually make AI work? How do you make AI successful? And interestingly enough, at Vicinity, we believe that that all hinges on your ability to access data, the right volume of data, the right variety at the right time. But getting access to that data isn't as easy as you might think. In fact, it was challenging enough that we figured we could create an entire webinar on this. So just going to leave that there for you guys to mull over a little bit while I go through the third and least interesting point, which is a little bit of housekeeping. So first things first, we are going to go through a how to Zoom. You've made it this far already, so hopefully this is mostly irrelevant, but just in case we need to brush off any remaining holiday cobwebs. First, when you joined, hopefully you've got the audio working by now. If you run into any issues, you can troubleshoot. There is a, I think it is three dots that say more. That's how you can troubleshoot some of your audio if that's the case. Otherwise, send us a note. We are recording this. Second point, let's try to keep this interesting. You found that webinars are pretty good if there's a conversation going. It's not as fun to just listen to someone. So we're not trying to make this a podcast. We actually just launched one yesterday. It's awesome. It's on our LinkedIn, on the social pages. So just take a look at that. But we do want this to be a conversation. So you've got a Q&A tab. Find that on your navigation panel. Feel free to pop in questions. That's going to go directly to me. And we'll be able to either answer those throughout the session or we'll answer them at the end. We do have a Q&A portion allocated after the presentation where we'll discuss some of those. And third, I already seeded it already, but as the one Q&A you can always count on, yes, this recording or this presentation is being recorded. We'll be sending that out probably tomorrow for your reviewing pleasure. So get excited for that. So overall, that wraps up housekeeping. Thankfully, we survived, so let's actually hop to the next slide. So, speakers, hey, it's me. We've met already. My name is Lisa, but we are actually here and most excited to introduce you to Steve Wallo, our Chief Technology Officer at Vcinity. Hey, Steve, thanks for joining.
Hey, Lisa, good to be here.
Excellent. So overall, Steve is responsible for bridging future IT trends into companies' existing portfolios, as well as their future offerings. In kind of relevance to today's conversation, which is a recipe on AI success, you can consider him our head chef, AI chef in residence, our data pioneer. So he'll really be talking about how data access is really one of the most foundational aspects to creating a future-ready AI program. So should be a really good conversation. And with that, I do not want to push this any further. So let's get this webinar party started. So Steve, over to you.
Thanks, Lisa. So I guess I am the chef today. I'm going to go ahead and go off a video here. So as Lisa mentioned, what we're going to talk about is just feeding this AI beast, this hungry beast. I'm going to give you the recipe. So I guess I'm your culinary expert today. What we're going to do is going to walk through the ingredients that work and then the ones that don't, right? So the whole idea behind this is to talk about not necessarily how to get into AI, but actually how to grow it. Okay. So that being said, here's the agenda. This is what we're going to do in a short amount of time that we have. As Lisa mentioned, right? What's the issue? There's tons of AI stuff out there, everything from, trying to find the goldfish to doing, advanced analytics on things like 8K video or stuff for transportation. But the issue becomes this term of locality. What in the world is that? So we're going to talk about what locality is and how it can affect the potential for growing your AI platform there. We're going to talk about where we fit in here. Somewhere in the vicinity is this really cool company I've heard of that can help solve this issue that we're going to talk about. So we'll show you some of those solutions. But most importantly, why does it matter? We're going to talk about some of the effects on people that provide the architecture, the infrastructure for these AI platforms. We're going to talk about the values that we bring to some of the developers and ultimately these end users. And then finally, I'm actually going to show it to you. So what we're going to do is we're going to show you a demonstration of this. It's a little bit different. A lot of things that we're going to talk about people don't think is actually possible. So we're going to show it to you. And I'm going to show you the story behind the magic. One thing to note this, normally magicians don't show you the tricks. So this isn't really magic, but we are going to show you kind of what's going on behind the scenes here. Okay, so that's the agenda for today. Now, first and foremost, it's the challenges, right? And then this isn't getting into AI. This is how do I make AI more effective? How do I actually grow that in my environment to do something really cool with it? What we're going to do is we're going to make this little pink brain on the other side here. We're going to affectionately call this Mr. Brain. We're going to make Mr. Brain very happy today. Okay. So a couple of things that are challenges to the growth. First and foremost, you guys have seen this, is training. It takes forever to get data into the model. It takes a lot of time to train the model. The more effective the data is, the larger the data set, normally you're going to get better training. Maybe, maybe not. We're going to talk about that. In some cases, it takes so long to get that data in. Is it still valuable, right? If your AI algorithm is based on kind of real-time insights, then the perishability of data becomes something we have to worry about. Okay, so how long does that take? How do I get that to be more efficient? We're going to take a look at how we can solve some of those problems. The other one is this concept of, is my result actually accurate or relevant? You heard Lisa mention hallucinations, right? I think our CEO talked about this in the past. This big term from the 60s and 70s means something completely different today, right? The idea is that, am I getting the results that I expected, right? If I'm looking for a goldfish, did I get a cat, right? These are some of the things that we're going to show how we can make that a little bit easier, a little bit more predictable, and a little bit more, effective in the end result there. And then the last one is this resource agility. And a lot of people don't talk about this. But this is one of the big challenges to AI growth, is the fact that, where is my resource? A lot of times you can't use just a small little compute platform to get some AI engines going. You got to find some bigger platform. Where does that sit? Where does it sit in relationship to the data? This whole concept of data locality that we're going to talk about. So these are the challenges. This is what we're going to spend most of the day focused on here. Okay. Now, what I'm going to show you here is this kind of the AI utopia. I will apologize. This is my version of a slide, so I'm not going to blame marketing on this one slide here. But this kind of gives you an oversight of kind of what we expect, right? It's the whole idea that I have this AI engine that's seen out there somewhere in the middle, and I have some data. Pretty straightforward. Then what I'm going to do is I'm going to put some software tools behind there to be able to do unique things with that. I'm going to have tools that help me do some data analytics, help me through some data scientist types of workloads. But the idea is I'm going to take my engine and my data, and I'm going to wrap it with these software tools to create essentially a product, right? And then hopefully that product is good enough that I can get it out into the real world for my users to do something with it and have some results, right? That's utopia, pretty straightforward. Our little brain down here on the left-hand side is all happy. Now, in comes reality. Here's what happens with reality, is that data is not usually where the engine is. If I'm using the cloud, is my data near the cloud? Probably not. If I'm using a core compute platform somewhere, is the data that I want to feed my AI engine anywhere close to it? Not usually, right? It's usually sitting somewhere at some edge location or multiple edges. And guess what? It takes time to actually move that data to get it close to the core of what we see here, which makes our little brain on the bottom left-hand side very unhappy. Okay. Then we compound that problem with it, which is that, maybe I'm not looking at one data source, right? If I really want to have relevant results, I probably want to look at more than one data type. And guess what? Those are usually not by the AI engine as well. So all of a sudden I've compounded this problem because my data is somewhere different than where I need it to be. And it's coming in from various sources that are all geographically distributed. And you see this little running clock, right? It takes time to do that. Now, The next piece is there's probably multiple AI engines. And as this technology matures, you're going to hear things like distributed engineering, distributed AI workloads, or nested AI engines, right? The idea is that instead of one piece of machinery or one piece of architecture working on a single problem, you're going to have multiples that work on a problem that is compounded back to some mothership that kind of pulls all these resources together. The idea is it's now this nested approach to solving these problems. And that can involve edge compute, that can involve a lot of cores, different clouds. But the idea is I'm compounding this problem. It's not just one single engine anymore and one single data source. It's really a lot of things that have been bolted together to get better results. Then, of course, we need multiple software tools, and you can see how this thing compounds. Now, the biggest challenge that we've seen so far, though, is, all the work that we've put together. Okay, so we've got all this data, it's coming from different sources. We've got some new software tools to help us do some advanced training. We're gonna do some inferencing. And did that actually work? Did my goldfish become a goldfish when I look for it, or is it still a cat, right? It's that feedback mechanism, which is making our brain over there on the right-hand side extremely stressed out, right? So what do? Well, in some cases, you can add in some diversified data kind of in real time. At least that's the hope behind it, right? It's the idea. It's kind of like building this big machine, and you spend all this time, you put it all together, and then you go to turn the key and nothing really happens. Well, some bright person decides to go over and just kind of kick the side, and all of a sudden it works, right? It's adding that last little piece to kind of bring in the tuning, to bring in the relevance of information to get the result that you're after. And of course, guess what? That diversified data is probably not anywhere close to, again, the core of the architecture that is doing this workload. So how do we solve this problem? What is the big issue? Time, right? You see in these little clocks here, this is one of the biggest problems with growing AI, right? We can put a lot of new horsepower and give you some big, huge compute processing. We can advance all these things to make that training process faster. But if it doesn't have the data, if there's no gas in the car, then we have this problem. And time is essentially related to distance, right? In other words, this kind of four-letter word, which is actually two terms here, data locality, right? The idea is that data locality is the problem, right? How do we get around data locality? And of course, what's the problem with data locality being in the mix here? Okay, the big deal, of course, is this time, right? It's pretty straightforward stuff. If I don't have any data, I'm not doing anything with the AI workloads, right? I need data to get in there. And if I can reduce that time, that's a big deal. But what happens if I get the wrong data, right? A lot of times people say, well, just feed more data in the engine. The more data that you can use in the training environment, the better. Not necessarily so. You want to have the right data. But how do you determine which data is the right data, right? Well, maybe I need to look at lots of data types and lots of different options to be able to filter things to see what makes the most sense, what has the relevance associated with what I'm trying to solve. Otherwise, I'm going to get the, wrong AI. And of course, we already mentioned this stale data. If my data is old, guess what? My results are old, right? And in some cases, it doesn't make a difference, right? We're looking for a fish. That's not going to make a difference. But if I'm doing things for, analytics for financial services or transportation or Fed space or government workloads, things like that, where I'm leveraging AI to make quicker decisions and quicker insights, I better have faster access to that information over distance. That's really what the problem here is, okay? Now, data locality, right? It's really related to latency, again, distance. So, we can try to minimize the effects of time. But the other side of the coin, though, is here, which resource do I use, right? One of the biggest problems with growing AI is, getting the hold of the data and getting the right data. The other thing is, where's the compute platform that I want to actually run my workloads? Do I use the core? Do I use multiple cores? Do I try to use the edge somehow? That's a little new. There are some new technologies coming up from the edge to, have edge compute kind of pull into this platform, or do I use the cloud? Right. And then the bigger concern is, okay, if I decide which core or cloud, or, I want to use cloud or I want to use core, which one do I use? If my data is somewhere in the US, do I want to use a compute platform that's in the US? What if all of a sudden I'm getting data from overseas, right? How do I pull these things together without having to move my workloads all over the place? So the idea is that I want to have the agility to be able to get to the data that makes the most sense for me to use and pick the resource that makes the most sense to use at any given time, right? I don't want to start in one location, then all of a sudden my data moves somewhere else and I have to move my resource. How do I glue these things together to get that agility, which allows me to pick and choose what I want based on, what makes the most sense from a financial, from a capability or performance perspective against the data that, is sitting somewhere out there in the architecture, okay? So something a little bit different. What can this cause? Real straightforward here. And we're going to talk about the solution. Hey, I can actually make bad decisions, right? That's pretty straightforward. I get bad results, then my decision making can lead to big problems. I can actually have incorrect business outcomes. It can be internal to the business, which could cause big problems, or it could be this perception that hey, this one company is providing this AI resource I can use, but then every time I use it, the decisions come out incorrect. That's a problem. Guess what? That company is probably going to go out of business, right? This is a big deal. The other thing is this workflow disruption. The idea is that if I have to continually tune, and you probably do to a certain extent, to make sure that my information is becoming correct and relevant, but it takes some cycles to go ahead and do that. And a lot of times people say, well, that's part of the tuning process in the AI algorithm. That's true. However, you want to make sure that when you're tuning it, you're actually making that process better, not worse. And that really relates to how effective my data is. If I'm always using the same kind of data types, I'm probably going to get the same results, right? If I can expand my reach and expand my information to bring in other things into the training model that might make or change things in a good way, that can really change this disruptive architecture. Okay. And then the last thing here is, of course, we have a potential of incurring cost. The last thing we want to do is get logged into a resource that might seem well, but as my data moves around or my decision-making paradigm starts to change a little bit, I might need to move to a different resource. I hope I'm not locked in there, right? That's a problem. That is definitely a showstopper for AI progress. So those are all the problems that we see here. And again, this isn't getting into AI. It's how do I grow this? How do I make a lot more information relevant to my customers? Okay. So what's the solution? Well, this is the horse versus the car mentality. There's a really cool quote from Henry Ford. You can see it at the bottom here, right? He said, if I asked people what they wanted, they would have said faster horses, right? Well, we're not trying to make a horse. We're not actually trying to make a car. What we're trying to do is build this rocket ship. You have to fundamentally change the paradigm of what's possible in order to really make AI grow. If I just give you faster processing, that helps. But if I still have this problem of getting my data, I'm still back to the same issue, right? So we have to solve it in a different way. I'm going to show you that, okay? So what we have to stop doing is, one, waiting for the data. How do we get to that data faster? How do we load it in faster? Or how do I get to it in real time? That's a little bit different. And how do I stop manipulating the data? Right? If you think about the kind of traditional approaches to solve this, a lot of it is, well, I'll just manipulate the data to make it look smaller, things like compression and dedupe and all that stuff, and then I can load the engine faster. Well, guess what? In the old days, when there was a human looking at information, that's okay. What we see nowadays is any kind of manipulation of the data can cause an artifact. And that artifact, even though the human eye might not be able to see it, an algorithm running on a high performance compute platform probably can. So a lot of times people, through business regulations or just the nature of what they're doing, think genomics or medical imagery or something like that. I don't want to have any sort of manipulation of the data. I want that raw, pristine information, right? So we're going to show you how we get that. And then, of course, we got to get rid of this term called data locality, whether it's at the edge, the distant core, in another cloud. So that's what we're going to stop doing, and we're going to show you the rocket ship here. Okay, so what is the rocket ship? What do we create? This is it right here. It's this idea, which is actually now a real thing that you can touch and feel. And again, I'm going to show you that at the end. But it's the fact that I can do AI from data anywhere. And the only way that works is if I can create this continuous data pipeline, right? I got to be able to glue the core to the edge and to the clouds. I got to put this stuff together so that I don't have to worry about which resource to use, where it's located, and where it's located in reference or relation to where my data is being created. It's affectionately called this intelligent data mesh. There's a lot of terms for it. In the past, you've seen it as, oh, it's a global namespace. Sure, that you can see everything, but in order to have good performance, you got to glue these things in together in a way that one of two things happen. One is that I can accelerate the movement of information from the core, the cloud, to the edge or the CSPs, and back in all directions. Whatever way I can speed this thing up, I'm going to make it a super highway, kind of the Autobahn out here. The idea is that if I don't move information around, I have a better, faster way to do that, again, without touching that information. Then we're adding in this other piece. And you see it at the bottom here. It says access remote data. The idea is that I can reach across this pipeline, reach across this mesh in real time. And I can augment the preloading to do the training. I can augment it with real-time things that are happening, events that are occurring in real time, right? Regardless of where they sit, to create this mechanism that gives me agility and information kind of feeding in all continually, all in real time. That's the utopia. That's what we're going to bring here. These are the ingredients to get rid of that one horrible, bitter thing called data locality. Okay. So a couple of things. What does this really mean to the people that are providing, the engine, the resources, the OEMs and the CSPs? A couple of things, right? One is we're going to reduce the time to get that data into the AI engine, right? If I'm a CSP or an OEM and I can go in there and say, hey, I would like you to use this particular piece of the architecture that I'm providing, and I'm going to give it so that you can move the data in and out a lot faster than anything else that's out there. Oh, there's some value there. That's a competitive advantage. The other thing is we want to extend the reach, right? I don't want to just look at information that's within 100 miles. I want to look at information globally. And that's going to create differentiation for the people that are providing these types of services. And then the last one is we want to have this resource agility, right? And then agility is really good for kind of the consumers, the customers of these folks. But also the idea is that, hey, if I have 12 different locations around the world, I want to make sure I'm not duplicating things just because somebody wants to use data in this section, but I have a capability that exists from a tool set or performance platform somewhere else. I don't want to make another copy and move it around because then I'm wasting my resources. The idea is to glue things together so that globally or regionally, it doesn't matter. Even to an OEM or a CSP, you pick the resource that makes the most choice to present to your customers. So these three things essentially are trying to remove the obstacles of data locality, right? How do I provide a better service? We talked about that. Now, from the developer perspective, it's kind of related, but a little bit different. The idea is I want to reduce these hallucinations, right? I'm going to get out of these 60s and 70s types of things, and I'm going to get into the 2020s and, get better outcomes. You see a lot of tools at the bottom here, but if I can get better data through data diversity and relevance, things like retrieval augmented generation, that whole RAG concept, right? It's the idea that, I want to bring in this last little piece of something that is occurring in real time. I trained the model, it took days or hours to do that, and all of a sudden there's one little piece that could really change the game, but it's way over there. If I can get to that in real time, then I can completely change the outcome of what I'm interested in, right? And then the final result is, hey, if I'm a developer, I'm providing some kind of software, some kind of executable to my customers, and there's a service level agreement associated with that. If I can, make that have less risk, meaning I'm doing things faster, I'm not running behind, or I can actually have a better SLA, there's a lot of value in there. So there's two kind of things to, the people that are providing, the architecture, the service to drive this whole project, and then the ones that are doing the development and using the tools to make this thing happen. Okay. So let me give you a couple examples here. So this little company called Vcinity did little work with the removal of data locality, one of two sides of the coin there, either move it really fast or this concept of this reach over distance to kind of solve and help you grow out of those issues associated with what we talked about in the beginning. What I'm going to show you here, these are some examples of just moving data, right? How fast can you move the data? And again, this doesn't involve any sort of manipulation. There's no compression, dedupe, none of those kind of old things. But I'm going to give you two examples here. At the top, pretty straightforward stuff. This is a 1 gig network. It's essentially East Coast to West Coast on the US, right? And we're going to show a comparison here. So what we did is we moved a terabyte of data across the country, and we did it once with Vcinity and once without. And you can see without Vcinity, it's a little over 10 hours. We move that terabyte of data. And then with Vcinity, it went down to a little over 2.5 hours, under 2.5 hours, right? So can you move that data faster? Yes. How much are you going to move per month? That's the big thing. You're usually not moving one piece of data. It's, continually moving information in to feed these elements. And if I can get, almost 4 times the amount of data through, that's a big deal. Our little brain on the right-hand side there is very happy. Okay. Now, if you think about the AI workloads, it's usually not 1 terabyte of data. It's usually in the petabyte range, right? So on the bottom, that's what we did. We said, okay, let's just kind of push this thing out. Let's push the limits. And on a 100 gig network, same thing, East Coast to West Coast, on a petabyte of data, instead of multiple days, in this case, a little over 4, we can do it in under a day, right? So again, this is an example of how fast you can feed that beast, right? Now, we take it to the next step. So this is that second side of the coin. And I'm going to show you both of these in the demonstration here. But it's the idea that, maybe I don't actually have to continually move information, full data sets into the AI algorithm, wherever in the world it sits. What kind of benefit can I get there? So on this chart here is an example. So in this case, there was a data scientist in Rio de Janeiro, and this is actually one of our customers. And they gave us these numbers here, and then they had the data set that needed to get back to Houston, where the analytics job is going to take place. Okay, on the right hand side, you can see, okay, to move the data, which is the blue bar, it took roughly 16 hours to do that, and then to run the analysis on that information was about 15 minutes. So that's the entire workflow. That's what they're normally doing. 16 hours and 15 minutes. Then we throw Vcinity in there, and we did the move in 2 hours instead of 16. So we took that down to 2 hours and 15 minutes. Drastic improvement, more effective results, better, insights a lot quicker. Then we spun the coin. We said, okay, well, don't actually move the data. Just have that AI algorithm reach across over distance and actually work on that data in place. And in that case, it took a little bit more than 15 minutes, but 18. So what we've done is we've taken it from 16 hours to 18 minutes. Again, this is what's possible. As I'm walking through this, we're going to talk a little bit about the tech. Today's not about the technology, it's about what it can do. And what I'm showing you is a completely different game changer, right? 16 hours down to 2 hours is pretty good. 16 hours down to 18 minutes completely changes what's possible with your business to use AI, right? This is one of those examples where the technology creates an environment where you have to completely think about a different approach because now you have possibilities that you never thought you had before. That's really what we're about today. Right? Now, I'm going to give you 3 kind of use cases here, and then I'm going to show you the demo. Okay. So the first one, this is some of the, advanced driver assistance systems, all that kind of fun stuff. Automated things throughout the car. Usually, if you're like me, you turn a lot of these things off, but how do we make them better? Okay. One of the things we've seen, lots of cars out there still collecting tons of information throughout these smart cities. I drive around all day, and then they collect a ton of data, terabytes of data. There's a lot of storage on the car. They come back to a garage, they unload everything into some kind of drive platform, and they put it inside the garage. And then remote people, remote engineers, developers, whatever, they reach across there and try to get to that information. Well, usually what happens is they make a copy of it, and then they take, 24 hours to push it back to some core architecture where these people are sitting, okay? That means that for every time that car runs, they're usually a day behind, right? If we could speed that up, that would be a great improvement, right? We can do that. But what we've also shown is this approach that says, okay, we're going to move the data. You have to have that through compliance, regulations, all that kind of fun stuff. But maybe the engineers can reach through the architecture and get information, start running those algorithms against that data that just got off the vehicles, or in some cases from the vehicles in real time, to kind of start working this process a lot faster, right? This gives these things a competitive advantage, gives the businesses a competitive advantage. You're improving driver and passenger safety, satisfaction. Maybe I won't turn the thing off, right? Enhancing collaboration. You can kind of see what's going on here. This is extremely something that is very relevant in the automotive, the transportation industry. We see this throughout, airlines, cargo movement, things like that. But this is just one example here that we wanted to put together for the automotive vehicle piece. All right. The next one is healthcare life sciences, right? We see a lot in here. There's a lot of AI development that is happening in this particular vertical, right? We'll want to make sure that we're able to grow that. This is extremely important. I mean, in some cases, this is, life and death, right? But the idea is that, hey, these images are huge. The talent that needs to take a look at this information, the doctors, the algorithms, are usually not sitting in a hospital somewhere. They're usually somewhere else, or maybe in a different hospital, or maybe a whole different location. We've even seen some of these folks working from home. But the idea is that if I can give this information to the doctors and the care providers so they can help these individual patients a lot faster, use these algorithms to do a lot of different things, right? Look at the images, see what's going on, fuse a lot of different disparate types of information that might be sanitized to take a look at trends, right? In the life sciences issue, are we seeing things pop up in different regions? Are we seeing something out here? AI is perfect for that, right? But the idea is, how do I get this information, back to the users, the developers that can do something with it? And fundamentally, if I can reduce the cost to the facility, maybe use that money doing something else, right? So very important stuff. I'm actually going to show you kind of a life sciences piece in the demonstration here, but it's pretty cool stuff, okay? And the last one here, and this is kind of neat. Actually, I kudos to Lisa on this one because she put this one together. But it's the idea that, hey, there's a lot of renewable energy that's out there. And one thing that I didn't know, but that is very relevant is, I got to store that somewhere because I might not be able to push it through the system the immediate, as it's being created. There's a certain balance that has to occur, whether it's solar or dumping into batteries or wind power or, hydroelectric where we're, just shutting the dam off, let the water kind of pull up almost like a voltage there that I can release as it's needed, right? But the idea is that, I need AI to help me kind of through that process, right? When do I release things? When do I turn them on? What happens if events occur? Things like, weather events, something like that. All of a sudden I have a hotspot that needs a lot of energy, but I have an issue because I can't generate it here. How can I move it somewhere else? This whole distribution issue, right? That's a lot of technology. It's very complex to make decisions on what to bring, to the users. It's not just on the demand, but all the other things that are affecting it. AI is perfect for that, right? But guess what? The data that's being created is, well, you're looking at a picture of it here in the middle of a field, right? I doubt there's a big, huge compute platform, something like a cloud or a core or something like that can be able to do something with it. So how do I get this data that's at this kind of stranded edge back into the core, right? That's what we're really talking about here, is how do I speed that whole process up? So a couple examples, a couple use cases, pretty relevant. I'm sure you guys have seen some of these things. So let's do this. Let me actually show it to you, okay? Now, one thing's going to happen here is I'm going to show you comparison. Okay, we're going to actually show you this technology. The best way for me to show, again, is comparison, but here's what's going to happen. One of the things that's always relevant to new technologies is it's got to be simple and easy to implement and use, right? I always tell folks, I can give you the greatest thing since sliced bread, but if you have to change half your architecture to do it, there's no value, okay? So as we walk through this, you're going to see that we don't care what the compute platform is. Again, we talked about the agility. You want to be able to use cloud, go for it. Pick the cloud of choice. You want to be able to use your cores, go for it. You want to be able to use the edge. We want to create a technology that allows you to keep that agility. Okay, so for the demonstration, I'm actually using the cloud. This will be on the West Coast, out here where I am in California. I'm going to have two instances in the cloud. We're going to do a comparison. So one is kind of the traditional approach. One is the one with Vcinity in there. And then my data that I'm going to do something with is actually on the East Coast. In this case, it's right outside of Washington, D.C., one of our offices on-prem, okay? Now, the only difference between the Vcinity solution and the more traditional approach is that little white circle of the rainbow V, okay? We're going to talk about this, but it's just a piece of software, okay? It's a bookend approach. I need something by the data, and I need something by the consumers of the information, that AI engine, right? How do I feed that beast? Well, I got a piece of software that's sitting there. Other than that, same network, same instance type, same storage. We really don't care. So let's go ahead and see what this looks like. All right. So what I have here, what I've done is I've just logged into this cloud environment that I'm running my instance on. This is the blue one. This is the Vcinity method. As I mentioned, we want to make sure it's simple and easy for people to use and implement, right? The last thing I want to do is add complexity into a complicated problem. So we're going to kind of keep this thing pretty simple. So the way it works is, it looks like a storage device. We're not storage. We don't want to be storage, but it looks like storage. So that's what you see, right? The idea is that I want to be able to present to the AI architecture, that AI engine, what looks like just a mount point, a folder. That's what you're seeing here, okay? This is actually a folder that's sitting on that instance that when I open up, looks like I'm sitting right beside data. Not really. This is actually the metadata or the pointers of the data that's still over there on the East Coast of the US, okay? But a couple things about this. One is that to the application, you don't have to do any rewrites, okay? I want to be able to augment my application, not have to worry about changing my application, right? The tool sets that I have, I want to be generic to the different tools. There's lots of them out there. If I can just look like a storage element or a mount point, off we go. I just say file open, I point to a different folder, and all of a sudden now I have access to remote data over distance. That's what you're looking at here. The other thing is, I have plenty of licenses on this, right? It just sits somewhere in the architecture and you just kind of point to it, okay? And then I also have here the traditional method, okay? There's two sides of this coin. There's two sides to kind of feeding this AI beast, right? Two ingredients. One of them is let's just move the data faster. Let's load in this massive data set to train the model quicker. And then the second ingredient is let's augment it with this ability to kind of reach across in real time and work with information that's thousands of miles away. So I'm going to show you two of those, right? So first is let's just go ahead and feed the beast with the amount of data that we have, right? So what I have here, I have a couple 10 gig files. Just random numbers. Again, this is not about manipulation of data. This is not WAN optimization. The idea is to keep that data pristine, keep it in the format that you expected, and feed that data naturally. So what we're going to do here is we're just going to take some data. We'll take this number 7, lucky 7. We're just going to drag it across. This will be from the East Coast up into this case, the cloud, but it could be the core, it could be an edge, doesn't matter. And what you're seeing is it's running about 9 megabytes a second, about 20 minutes. This is using the internet, by the way. Just for the record, it's about 700 megabit connection, but just standard stuff, nothing super fancy. If I do the same thing on the Vcinity side, we'll come over here, we'll take number 7, drag it across. So same network, same data, same instance. And instead of 8 or 9 megabytes a second and 20 minutes, what you're going to see is, 70 something and 2. So all of a sudden, just using the internet and a drag and drop, I'm getting 10x the performance improvement. So if it was taking me 10 days to load my information into a training model, I can potentially do that in 1, right? This is a big deal. Now, one of the things that's kind of unique about Vcinity, and I don't want to spend a lot of time on the technology here, but I do want to show you this. And this is one of our management tools. And what you're seeing here is this little circle. It says, it's a little green circle. It says 97%. Okay. That's our ability to sustain throughput over distance. Remember, distance, time, latency, data locality is the end result, right? Is because of the fact that there's just distance, right? There's delay, there's time associated with it, kind of in the middle. How do we remove that? Well, if I can sustain over distance whatever I put in, and I can make sure I'm getting pretty much the same thing out the other side, that's one of the ways we do that. And if you think about it from a normal networking perspective, I can fill up a pipe of data, sure. But then at the other side is kind of dribbling out the other side. I can't keep it sustained. One of the things that we've done, and you're seeing it here, is the fact that whatever I put in, I'm going to get pretty much the same result out the other end, which means I'm minimizing the effect of distance. I'm allowing you to not have to worry about data locality and remove that kind of variance of time. Okay. So that's one thing. Traditional data move, pretty straightforward, pretty easy to understand. Now let's soup it up a little bit, right? Let's add some spices to this mix of things that we're going to feed this AI beast. Hopefully he likes steak and potatoes, but we're going to make it a little bit more interesting here. So let's do something with healthcare life sciences. I promise we're going to do this. So here's what I have here. This is a DICOM viewer. For those that are familiar with, a lot of medical images are based on this kind of DICOM format. This is just we're just going to read it. Again, I don't have access to a big, huge AI machine, nor do we want to spend, some number of hours waiting for the algorithm to train. So we're just going to give you some kind of high-level examples here. So here's what we're going to do, is I'm going to take this DICOM viewer, and I'm going to just have it read an image that's, in this case, 2,800 miles away, okay? This was kind of cool because this is actually a COVID scan. So what we're going to do is we're just going to open this up. We'll start on the traditional side here, and I'm just going to double-click on COVID scan. And we'll do the same thing over here. This will be the Vcinity moment. And there's my COVID scan. I'm going to click that. All right. So if we come back to traditional, that's what we expect. Get that little blue circles kind of spinning around. If I come over here to the Vcinity side, there we go, 77. There's my scan. Okay. If I'm a remote doctor and I need to look at patients or lots of different things over distance, this is a much better approach than, well, what you see here, which is this blue circle. If I am an AI algorithm, right, and I'm going to look at multiple pieces, I'm going to do, trends or data fusion. The last thing I want to do is have this little blue circle, right, or wait days to move the information in. In some cases, it makes sense. And in some cases, you want to have the option to do what you see on the right-hand side here, which is immediate access to information over distance. Okay, so that's something kind of cool with the life sciences there. So let me show you one more. We're going to go ahead and stop this. Close that. Okay. So what I have here, let's do something in energy. We mentioned energy. What I'm going to do here is we're just doing some 3D modeling. Okay. There can be a lot of analytics associated with the energy platform here. This is actually 3D modeling for seismic survey data, right? The idea is that there's a boat that goes out in the ocean. They do a sensor sweep of the ocean floor to, well, see if there's oil there or not. This is energy creation. Exploration, right? There's tons of analytics associated with that. This is just a simple little tool. But the idea is I'm going to run this tool on a platform, in this case, cloud, but it could be the core on one side of the coast. And then I'm going to look at data that's on the other side. So I'm going to start here on the traditional side. We're just going to add in some layers, right? Come back over here to the Vcinity side. I apologize. There's a lot of windows going on here. So there's my options. Okay. So traditionally, here we go. You can see it's got, make sure it's smaller. There we go. All right. So we're going to select all the layers on the traditional side. We'll do that first. We'll come back over here to the Vcinity side. We'll do the same thing. We'll select the layers. You see the checks come up. I hit OK. And now what's happening is I'm literally doing 3D rendering where my compute and my data are 3,000 miles away, but I'm getting the same result as if the data had been sitting right beside me, which means I remove the effect of data locality. If I come back over here to the other side, this is the traditional method. This is what we'd expect, right? Without Vcinity, you move data around, you wait, you hope it gets there in time. It's a big problem. You have lots of copies. You have to do data management. You can see all these things that are compounded. I'm not being able to feed that AI beast. It says, as Katie mentioned here is on the call, it's kind of growling at us because it's hungry, right? So how do we solve this problem? And I'll hit OK, and it takes about 20 minutes. We're not going to wait for that. Okay. So I do want to show you a couple examples here. And again, we're going to open up for questions after this last slide I'm going to show you. So let's go back to the deck here. The idea is that, okay, what's happening? I don't want to get into the technology itself. You guys can reach out to us. There's going to be some links at the end. We could talk about the tech in deep detail if you want. But a couple things that we need to kind of push out here. One is, how do I ingest information? How do I present information out, right? I already showed you through the demonstration that would look like a storage device. Okay, so the way that I get to data, which is on the left-hand side here, looks like a pile of Oreo cookies that we're going to feed this beast, right? It's through standard storage protocols, NFS, S3, things like that. Our software just ingested through storage protocols, NFS clients, all that kind of fun stuff. No changes, everything looks pretty good. On the right-hand side, we present back out the other side, kind of the same way, right? So just normal storage protocols. So to the edges, it's just something that they understand. There's not a license that you have to put on there, just the stuff from us, but you don't have to make any changes to the storage or to the machines or to the platforms or to the software or anything like that. In the middle, we're not using normal things. We use some high performance computing protocols, but then we wrap it in normal things so that it looks like, standard IP packet running down the wire, which means we don't care what the network looks like, right? It can be the internet, it could be dedicated links, satellite. You want to get to remote locations. Maybe I'm doing media and entertainment analytics or post-production stuff, right? I want to get out to, the set, which might be somewhere else. The only way I can get there is through satellite, right? I'll be able to pull those things in there. I want to do some AI workloads. Same thing with oil fields. I want to get to the offshore oil rig, a remote hospital. You name it. The idea is that I don't want to have to worry about the transport. That's okay. The solution allows us to be transport agnostic. But the idea is we do some unique things in the middle. We create that secure connection. This is a very secure thing. And then it allows you as a user, as a developer, as an OEM, as a CSP to kind of feed that AI beast, meaning, I either move the data really fast or we'll go ahead and reach out over distance and do something kind of unique with it. Okay. So in summary, here we go. Right. We had the first slide that said, what are the challenges? So we had that little Mr. Brain over there had a bunch of question marks. We should have put a happy brain back over here, didn't. But the idea is that how do I get more efficient and effective training, right? I need to be able to feed that machine faster with larger data sets, right? Or I need to be able to augment it in real time, over distance to make relevance, to create diversification in the data, to be able to tune it with information that actually creates a good tuning as opposed to just kind of spinning the wheels and feeding it the same information, right? And then the last piece here is, we want to have that agility. We want to make sure that you as a consumer, as a developer, as an integrator, as a manufacturer of information, that you have the ability to create differentiation in what you're doing, to not have to worry about locality, to not have to worry about being locked in, meaning if I'm, a cloud provider, I don't want to have to move information between regions just because I can't reach across all that kind of stuff, right? That's really the three things that we kind of brought into this architecture to solve those three challenges that we saw up front. And the idea is that the whole concept is to avoid the issues with data locality. Okay, so that being said, that was our slideshow for today. So Lisa, is there anything out there that people want to hear about?
Okay, back on mute. Perfect. And Steve, I'm actually going to make you come back on video as well. So it's something more interesting to look at than just a slide. Sure. Thank you. Okay, perfect. So I plugged this into the chat. There are a few questions that have started already. But as you have them, pop them in. I will be fielding them hopefully accurately over to Steve. So we'll see how that goes. But the first one that came through actually quite a bit ago was you talked about one of the ways is getting data or kind of data to the AI model is through this point-to-point movement. But what happens to some of the data when you can't actually move it? So, for instance, you had mentioned one of the examples was AI patient data processing. We also hear a lot about genome sequencing, for instance, and perhaps you can't move all of that data out of a hospital, whether it's through for HIPAA or the hospital just doesn't want to let go of those records. How can you work around data that can't be moved?
Sure. Yeah, good question. So a couple things about that. One is, this technology is not going to solve GDPR or something like that, but what it's going to do is it's going to give you options, right? So part of the way that technology works, so you have this ability to say, okay, I want to move the entire data set. Great, we'll move that. But then this concept of I want to reach across over distance in real time and work with information and keep it in place. You still have to move something, right? But what's happening is you're only moving the pieces of interest that an application is asking for. So let's say you take 100 images, we'll do healthcare, right? We got 100 DICOM images and a doctor remotely says, I really only want to look at 3. We're only going to move those 3. When the application says I want these pieces, that's all we're going to move. And then because of the way we do that, if the doctor says, okay, I'm done with it, because we're not storing anything, that all goes away. So now what happens, you can have a conversation with those folks that say, I have sensitivity, I have regulations, I have compliance, HIPAA, things like that, that mean that I can't make a copy of my data and move it, but you might be able to access it and read it and do things with it, but then not store it. So there's a lot of different variances through that, whether it's life sciences or financial services, right? A lot of
Mhm.
times people can't move information. So, you can have a discussion that says, well, I'm not really moving it or I'm not storing it. Is that okay? Can I help those types of things out? So hopefully that was a good answer for that question. It's a good question.
Perfect. We'll let you continue answering a few more.
Be gentle.
You haven't been asked to leave yet. So actually related, kind of related to that. So not necessarily just data you can't move, but as you're talking about today, one of the biggest kind of points of value here is being able to make sure the right training set is available or the right data set for that. How can you go about this? I think you might have mentioned there's something called RAG
Mhm.
that's valuable.
Sure. Yeah, absolutely. And it's funny because you mentioned the term right. How do I get you the right information? So, we can't predict what the right information is, but what we can do is give you access to all the information so then you can make choices that have a whole plethora of information rather than very specific things, right? If I'm looking for a goldfish, why am I looking at pictures of the desert, right? I want to look at different things. I want to look at, the thing when I was a kid in my room that needed to be cleaned, right? That there was a goldfish in there. Those are the things that we want to look at. So the idea is that, we can't make that decision, but we can afford you the opportunity to have all the information out there to be able to curate, to be able to filter it so that now you're not basing your outcome on small little data sets, but a lot of things that hopefully give you options.
Yeah, and I'm gonna throw in on top of there just because we've had some conversations with companies that were moving incredibly large data sets. They were talking to us and said, "Hey, this actually takes us a week to move the data. So every time we have our data scientists, very well paid data scientists, sitting for a week, we're waiting for this data to get to our site. They run the analysis that takes maybe what 30 minutes an hour. You find, oh shoot, we probably need to tweak it, and then you need to report that data set again. So not only I think the ability to access the right training data, but also those productivity gains or the ability to deploy the model much more quickly based on those findings is incredibly relevant here as well.
Yeah, no, I agree. And just to add into that really good insight you had was in some cases, people they realized that the data they got has a problem just inherently. There were bad pieces, there were missing pieces, the capture didn't work, the collection didn't work, and it took them a certain amount of time to figure that out, right? Even if we can speed that process up, instead of it taking a day, we did it in an hour, but you still got to wait an hour to figure out you have bad data, right? So we've seen people use the combination of, okay, I can move it faster, but let me take a cursory look at it just to make sure there's no holes
Mhm.
in it, that everything was working, right? We'll take a look at that information. If it looks good, then we say, okay, cool. Now let's go ahead and move the entire data set faster. So yeah, good point.
Cool. And just related to moving as well. So, in the collection process or curation process, Do you have tools to move the differential, so only the new part of the data?
Yeah, we actually do. So part of the file system that we have inside our software allows you to move the differences, right? It does it, whether it's metadata differences or the data of interest, right? If anything has particularly changed, then we can move that information. From a technology perspective, we don't have to, but we can turn on caching, so you have kind of a localized copy of it. And then, of course, if you have multiple locations working, you want to make sure you have cache coherency, right? The ability to say that, okay, I've the same data in multiple locations that people are working on. If somebody changes one, to make sure that a change occurred over there, so everybody's kind of in sync, right? That's something that is kind of inherent to our technology. So kind of a little bit of a geeky answer there, but yeah.
I was thinking easy in the data governance. There are a lot of benefits there, lower storage,
Sure.
all sorts of great things. So that's fantastic.
Mhm.
Related to just as we're talking about moving data from kind of a point to the AI application, there's also you were mentioning this concept that hey, by removing data locality, you can access data at the edge, at a core, any cloud. Does Vicinity actually remove the need for edge compute?
Oh, good question. Yeah, we get that a lot. The answer is no. Edge is really good because here's what happens. And if you think about it from an AI perspective, right? Think about filtering and curation, right? The whole idea behind, edge compute is, if it's a small little element, you can probably do everything there. Then it's just a stranded edge. But normally what's happening is those edges need to connect back to other edges or back to a core or back to a cloud. So I can do curation, I can do filtering to say, okay, I'm looking for this goldfish. I have that whole ocean here. I'll pull it down into something that, a goldfish might sit in. And then I'm only going to move that, right? There's a filtering mechanism associated there. That's very powerful, and that's a very good complement for edge compute because you want that processing at the edge to do those things. However, what you don't want is this really great curation, filtering, processing, and then you sit around and wait, right? I want to be able to have that edge not be stranded anymore, but have complete autonomy back to kind of the AI mothership so that I can take full advantage of that stuff in real time, right? One of the other things that's interesting, we kind of saw this actually out of the high performance computing industry that they were talking about AI, which is, they let's say they had 10 edges and they said, okay, each edge is going to filter or curate, independently what they think is important across those edges, and they got all the information back. But what they realized is that the parameters they were filtering on were based on each edge. Okay, this edge has these, I'll filter on this. This edge has. If they looked at the entire data set as a whole across all 10 edges, there were other things that popped up that were common across them that they could only see from a higher level across all of them. And we're the only technology that allowed them to do that. So now you can tune the filtering algorithm so it's not independent, but it's more of a holistic view of things to get different results. So there's a lot of different ways that edge compute kind of complements what's going on here. Yeah, good question.
Less hallucinations. We like it.
Yeah.
Always a good thing. So speaking of one, the kind of the scale and diversity is driving us to reduce those hallucinations because we are able to have greater transparency across the data set holistically because we can move the data there in time. One of the other things that can drive kind of a bad output is bad ingredients. So how can you ensure as you're moving the data or remotely accessing it, whatever it may be, that that data is actually secure. I think you mentioned, for instance, we're not a WAN optimizer, so we're not kind of manipulating the data in any way. Kind of, what are some of the thoughts there?
Sure, absolutely. And it's funny because, you know, so let's say I'm a chef today and I really can cook, but if I am a chef and I've
You're not
always
going to be able to get this out of your head. I'm sorry.
seriously, I'm gonna be grilling on the weekend thinking about AI algorithms. But the idea is that, I can start with, here's my recipe and I have all these ingredients. And what's the number one thing that people always say to a chef? Use fresh ingredients, right? It calls for, I don't know, apples. And if my apples are bad, I completely hosed and my beast is going to be upset, right? So that secure piece is one, we want to make sure that, we're getting the data in real time. But two is, yeah, how do we secure it? Because you want to remove the risk. So we have the ability to do a lot of different things from a security perspective. One is we augment the security algorithms and the security attributes that are out there, the permissions, the locking, the directory structures, the Active Directory, if you're doing that, all that kind of stuff. We don't break that paradigm. what we do is augment it by able to do things like in-flight encryption, or the ability to do obfuscation by moving data across multiple links and putting them back together. And there's a lot of different components that you can bake into this to make sure that, yeah, just because you have the ability to reach information over distance, one, are you allowed to see it? By policy, can you change that, right? I don't want to just open everything up and then have everything be viewable. I don't control that. And then two, make sure that when you do move what information we're going to move, you do it in a very secure, predictable manner. So yeah, good point.
Awesome. And I'm trying to monitor the time here. I'm going to throw out one more question. This is where I get to play MC privileges. So this is mine.
Uh,
Don't judge the audience. This is mine, maybe a bad one. But just as the beginning, we were talking about, one of the things I mentioned is that there's so much potential impact with AI, but there's still a lot of struggle to say, how are we designing future ready programs? How are we helping our AI projects not fail? So in that mindset, how can Vicinity help my AI program actually scale, be successful, scale?
sure. So if you go back to the beginning of the webinar, the first thing we said was we're not going to show you how to get into AI. We're going to show you how to grow AI, which is essentially scale, right? How do I make it more relevant? How do I bring it to the masses and do different things? And the only thing that there's a lot of impediments, but what we bring is that ability to get to the larger pool of information, right? If I can,
Mhm.
I'm going to look at, if somebody's looking at a goldfish, great, I can give you access to information associated with that goldfish. But then you take it out to the industry and people are like, I really want to look at a monkey today. Okay, well, how do I get information across all that? How do I increase my data set? How do I scale that so that I can scale my business model to take advantage of the AI product that I've just created, right? So yeah, this is an interesting webinar. We're talking about fish, goldfish and monkeys today. Yeah,
And food, you're like, technology has suddenly become so interesting.
yes.
But
Yeah, there you go.
no, that's great. If anything, I think this makes it kind of easier to think through and sort through. I do notice we are just about at time, so I want to be mindful of everyone's schedules, including yours. So we're going to wrap things up. If you actually want to jump to the next slide and just go through a couple quick things. So one, I know there were a couple more questions, but if we didn't get to your question, or if you were thinking of one you did want to ask, please feel free to reach out if you've got a Vicinity rep. They're going to be really excited to hear from you. If you don't, you're probably going to start receiving a couple emails like the recording of this webinar. That's a great place to start. Also, a quick plug, if you loved this conversation, but you spent the entire time thinking, hey, I wonder what this means, or if we could talk about this through the lens of a government or federal space, you are actually in luck. We're going to be hosting our next webinar around AI in the federal space. That's going to be taking place in March. So stay tuned for details there. And then last but not least, quick round of thank yous. So Steve, as our kind of incredible speaker, our AI chef, our technical evangelist, thank you so much for spending your time with us, sharing some of these insights. This is awesome. Apparently we now know that the AI beast it can be tamed by feeding data. So now I guess I will forever be thinking of this as AI being the Ken Tinker's dinner guest. Not necessarily something I wanted to walk away with, but thank you. And for everyone on the line as well, we really appreciate you being here. I know we are still in a very, very digital world that does a lot of remote. So there's a million places you can be. So thank you very much for choosing to spend the past hour with us. It is most appreciated. And with that, let's close. Thank you again, everyone. Watch out for a recording of the session. It should be coming out probably tomorrow morning. And other than that, we look forward to seeing you in March. Sounds great. Thank you.